Write the heading complex integration. First you write the definition. For complex integration. Complex integration. So what is the definition of complex integration? Listen. You know that ordinary integration. In the ordinary integration, we have seen that some y equal to f of x is given. Some y equal to f of x is given. Some curve is there. In the curve, in the line integral, we have subdivided into some parts, and then summation of all the integral can be written as integral over a to b in case a lower bound, b upper bound is there. Integral over a to b f of x dx is that the simple integral, and it is denoted by I. Okay, similarly the complex integration is, write down the integral of a complex function the integral of a complex function is defined as the integral of a complex function is defined as you want coming is defined as the limit of certain sum certain sum in the same manner the integral of a complex function is defined as the limit of a certain sum. Okay, in the same manner as integral of real function along the x-axis is defined. So here I take the coordinate system xy. Here I take the coordinate system xy and then take two terminal points A, B. Here I take two terminal points A and B, and then here I am taking that A is some P0 and then B is some Pn. Now we have to divide this curve. We have to divide this curve to P1 to Pn. Then here we can write, let f of z. So previously for the simple integration we can take y equal to some f of x. Here we can take f of z, w equal to f of z. So let f of z be a continuous function. Let f of z be a continuous function of a complex variable. Let f of z be a continuous function of a complex variable z equal to x plus iy defined at every point of a curve defined at every point of a curve C. Take that curve is C. F of z be a continuous function of a complex variable z equal to x plus iy defined at every point of a curve C, whose endpoints are A and B. Let divide the curve C. Let us divide the curve C into n parts. So we are dividing the curve C into n parts by the points A equal to some P0, next point P1, next point P2, and then terminal points B, not Pn. Terminal point is B. Let we take delta Zi equal to Zi minus 1 to Zi, and let epsilon I be a point on the arc epsilon I be the point on the arc Pi minus 1 to Pi, then the limit of the sum summation of I equal to 1 to n, summation of I equal to 1 to n f of epsilon I delta Zi as n tends to infinity as n tends to infinity, in such a way that each delta zi tends to 0. If it exists is called, if it exists is called the line integral of f of z line integral of f of z along C, along the curve C, and it is denoted by integral over C f of z dz. Next definition, simple curve. Simple curve. A continuous curve which does not have a point of self intersection is called simple curve. The simple curve are called Jordan curve. Jordan Jordan curve. It is a MCQ definition. Simple curve, a continuous curve which does not have a point of self intersection, is called a simple curve. Listen, it is a simple curve. One line is a simple curve, and then there is no self intersection, means there is no intersect in middle. That means, in case if we take one circle, starting point and ending point is there, it is simple closed curve. It is a simple curve. Okay, it is a simple curve. It is simple closed curve. It is simple closed curve. Okay, if any region is there, if it is a region, then it is known as that simply connected region. Simply connected region. It is a simple curve. Okay. Then multiple curve. Multiple curve is known as multiple curve or multiple connected region. See, multiple curve means the curve which has that intersection. That means if a curve intersects itself if a curve intersects itself is called multiple curve. Multiple curve. See, for example, if I write the curve like this, if I draw the curve like this, see here it is crossed itself. It is crossed itself. So it is that multiple curve. See, one more example I can write here. Okay, here one curve is there. Here one curve is there, but it is not closed. Okay, this it is self closed. Okay, fine. So it is not closed. The two curves are there. Then how can we draw it as a simple closed curve? Simple closed curve means if we draw that one line here, and then if we draw the one line here, the two curves are connected, but it is not self intersects. Therefore, it is known as that simple closed curve or simple curve. If it has some intersect is there in middle, that is known as that multiple connected region and multiple curve. Okay, and then one more thing here, it has many intersects points in middle. It has many intersects points in middle. That points are known as that multiple points. That points are known as that multiple points. I didn't write the definition here, but the book is not given the definitions. Just I'm telling what are mean by that multiple points. One important, very, very important, the theorem is there. One compulsory question will come based on this theorem. The theorem name is Cauchy's theorem. Cauchy's theorem. Or Cauchy integral theorem. Cauchy integral theorem. Cauchy's integral theorem. Not integrals is there, only integral. Cauchy integral theorem. Okay, fine. So how to define the Cauchy theorem or Cauchy integral theorem? Write the statement for this. Statement. If f of z is analytic, and f dash of z is continuous, f dash of z is continuous at all points, inside on a simple closed curve C, inside and on a simple closed curve C, inside and on a simple closed curve C, f of z is analytic and f dash of z is continuous at all points inside and on a simple closed curve C, then integral over C f of z dz equal to 0. then integral over C f of z dz equal to 0. Even you can put that two important sign for this, because compulsory it will come. Cauchy fundamental formula, Cauchy's integral formula, Cauchy's integral formula or Cauchy fundamental formula, Cauchy's fundamental formula, Cauchy's fundamental formula, Cauchy integral formula or Cauchy fundamental formula. Problem will come based on this. If f of z is analytic, if f of z is analytic and f dash of z is continuous, f of z is analytic and f dash of z is continuous, and if a is any point, a is any point, a is any point inside curve C, inside C, then f of a equal to 1 by 2 pi I integral over C f of z dz divided by z minus a, where a is known as the singular point of the integration. Okay, fine. Now listen, here we can see that what is the formula here? F of a equal to 1 by 2 pi I integral over C f of z dz divided by z minus a, provided a inside that circle. A inside the circle, provided a should be inside the circle. If a is outside the circle, the integral will not exist. The integral will be 0. If a is outside the circle, the integral will be 0. If a is inside the circle, then only the integral is exist. Okay. So here this formula also can be written as integral over C f of z dz divided by z minus a equal to 2 pi I into f of a. Okay. The same formula can be written as integral over C f of z dz divided by z minus a equal to 2 pi I into f of a. Okay. So based on this formula only, we are going to do some problem. evaluate integral over C. In case if we write that circle here in the integration, it is known as the closed curve. It is known as the closed curve. Integral over C on the closed curve e power minus z by z plus 1 dz, z plus 1 dz, where C is the circle, where C is the circle, where C is the circle, 1 mod z equal to 2, comma, second one mod z equal to 1 by 2. So this is the problem. Here given that evaluate integral over closed curve C e power minus z by z plus 1 dz, where C is the circle, mod z equal to 2, second one mod z equal to 1 by 2. So we will discuss that problem one by one for each case. Okay, so here write the solution for this. Write the solution for this. Write the solution for this. Let the singular point is z equal to, listen, in the denominator z plus 1 is given here. Z plus 1 is given here, is it not? For that z plus 1, you can compare with that z minus a. Okay, so what is the singular point? A is the singular point. So what will you get? Minus 1. Z equal to minus 1 is a singular point. Z equal to minus 1 is a singular point. Is it clear? Okay, fine. Now see the circle. Also given that first case you can take mod z equal to 2. Mod z equal to 2. Mod z equal to 2 can be written as root of x square plus y square equal to 2. That means x square plus y square equal to 2 square. What is this formula? This formula is that equation of the circle with the center, origin and radius. Radius is what? 2. Okay. So therefore we can draw one circle here. In the circle, origin is 0, 0, and then radius is 2 here. Radius is 2. Okay, fine. By the Cauchy integral formula, write down Cauchy's integral formula. By the Cauchy integral formula, f of a equal to, already written here, 2 pi I into f of a, 2 pi I into f of a equal to integral over closed curve C, f of z dz divided by z minus a. Okay, fine. Now we have integral over C, closed curve C. What is given here? E power minus z by z plus 1 dz. Is it not? That is equal to 2 pi I into f of a should be there. What is f of a here? A is what? What is a here? Minus 1. So we have to write that 2 pi I into f of minus 1. So what is f of z here? Numerator is f of z. Actually, the numerator is f of z. So, what is numerator here? E power minus z. Then, what is f of minus 1? E power minus of minus 1. That means e. Okay. So, f of minus 1 is e. F of minus 1 is e. Substituting f of minus 1 in the equation, we get integral over c e power minus z divided by z plus 1 dz equal to what is value? 2 pi I into e. Second case. What is the second case? Given mod z equal to 1 by 2. Okay. Mod z equal to 1 by 2 means square root of x square plus y square equal to 1 by 2. That means x square plus y square equal to 1 by 2 whole square. It is an equation of the circle with the center at the origin and radius 1 by 2. Okay, na? Now listen. Now you can draw the graph. Now you can draw the diagram for this. So okay, fine. It is radius is off, and then center is 0 comma 0. But what is z plus 1? How can we write that z plus 1? Z equal to minus 1 na? Z equal to minus 1. Where that z equal to minus 1 is there? Listen. Z equal to minus 1 means x plus iy equal to minus 1. X equal to minus 1, y equal to 0. What is that point here? Minus 1 comma 0. Where is that minus 1 comma 0? Here. Minus 1 comma 0 is outside the circle. Okay, listen. In the Cauchy integral formula, two things are important. One is you have to identify that singular point, which is based on the denominator. Okay, next one is circle. Okay, now listen. You draw the circle whether the singular point inside the circle or outside the circle. If inside the circle, you can go ahead for do the integration or finding the value. If the point outside the circle, just you can put 0. Close your eyes, put 0. That's all. Nothing to calculate. If the point outside the circle, integral value is what? 0. Okay, fine. Now write down the singular point. Z equal to minus 1. The singular point z equal to minus 1 lies outside mod z equal to 1 by 2. Therefore integral over c e power minus z by z plus 1 dz equal to 0 by Cauchy theorem. Listen, that integration value is 0 or having some value based on the circle, not based on the singular point. Okay, so you have to identify that singular point properly, and then you have to identify whether the singular point inside the circle or outside the circle. Problem to problem it will be vary. Okay, fine. Second problem, evaluate Second one, evaluate. The same problem repeats many times. Can put that important sign for this problem. Evaluate integral over closed curve C cos pi z square divided by z minus 1 z minus 2 dz, where C is the circle, where C is the circle, where C is the circle, mod z equal to 3. Where C is the circle, mod z equal to 3. Fine. Write the solution for this. Let the singular points are what are the singular points here? Z equal to 1 and 2 in the denominator. In the denominator, Z equal to 1 and Z equal to 2 is there. These are the singular points. Okay. Given the circle, given the curve, the circle, what is circle is given? Mod Z equal to 3. What is this? Center is 0, 0 with radius is 3. Radius is 3, not 1. Radius is 3. Okay, fine. So when the radius is 3, singular points are inside the circle or outside the circle. You can draw the diagram for this. It is a radius is 3 here. Radius is 3. So Z equal to 1 and 2. Z equal to 1 is here. Z equal to 2 is here. So both that points are lies inside the circle. Therefore, both singular points lies inside the circle. Both the singular points lies inside the circle, mod Z equal to 3. Now, listen, that f of z by z minus a, z minus b is there, na? That is not the case. We are not able to calculate this. Therefore, we can write that 1 by z minus 1, z minus 2 can be written as a by z minus 1 plus b by z minus 2 we have to write. So it is that method is what? Partial fraction method. What is the method called? Partial fraction method. Using the partial fraction method, you will get that directly I am doing here minus 1 by z minus 1 plus 1 by z minus 2, but you have to calculate. Here I am writing the directly, but it is a very simple problem. You can calculate that by partial fraction method. Minus 1 by z minus 1 plus 1 by z minus 2. So you can substitute this value here in the integration. We will get that what is given here, integral over c pi z square, sorry, not pi z square, cos pi z square divided by z minus 1 z minus 2 dz can be written as integral over c cos pi z square divided by z minus 1, but minus is there outside, dz plus integral over cos pi z square divided by z minus 2 dz. It is closed curve C. It is closed curve C. Okay, fine. Now listen. That means if that function given as a two singular points, that time you have to separate this by using the partial fraction method. Okay. So after that, what is this value of the integration? By using Cauchy integral formula. What is the Cauchy integral formula? We can write that integral over C f of z dz divided by z minus a equal to 2 pi a into f of a. Okay, so what is this value? First one value. What is first one value? Minus is there, minus put here, and then 2 pi I. F of a means what? For the first one, what is a here? 1 is, so f of 1 we can write here, plus 2 pi I. What is a here? 2, so we can write that f of 2. What is f of 1, f of 2? What is f of z first? Cos pi z square is f of z. Therefore, what is f of 1? Cos pi, yeah. Cos pi. Cos pi is what? Minus 1. What is f of 2? Cos 4 pi. What is cos 4 pi value? What is cos 4 pi? Array. Cos pi is minus 1. Cos 2 pi is plus 1. Cos 3 pi is minus 1. Cos 4 pi is plus 1. Okay. Therefore, we can write, substitute here, minus 2 pi I into minus 1 plus 2 pi I into plus 1. So, 2 pi I plus 2 pi I equal to 4 pi I. Okay. So, this is the answer for this. Therefore, integral over C cos pi z square divided by z minus 1 z minus 2 dz equal to 4 pi I is the answer. Okay. So what are the things you have to be concentrate here? One is you have to identify the singular point. Second one is identify the circle. And the third one is whether the singular point inside the circle or outside the circle. Inside the circle, do the calculation. Outside the circle means no need to do the calculation. Directly you can put simply 0. Is it clear?